It's possible to countersize 1023 only on 10 fingers, although there is no theoretical limit due to the implications of the method of counting to 1023 on 10 fingers. Well, so obviously, if you're counting to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that's the usual way, typically for, I don't know, I argue most people, how they count. And, it's based on the amount of fingers that are up, that indicates what number you're on, right? However, you could, making use of base 2 or binary, which uses number 0 and 1, which can correspond to a finger down or a finger up. In the binary counting system, each places twice the value of the adjacent left space, just how, like in base 10, each places 10 times the previous space. In base 10, you've got the units, the tens, the hundreds, thousands, 10,000s. You multiply by 10 each time, and so like 10, that's 10, 100, that's 100, which is 10 times 10. Anyway, yeah. In base 2, it goes 1, then times 2, that's 2, times 2, that's 4, times 2, that's 8, times 2, that's 16, 32, 64, 128, 256, 512 for 10. Wait. Because you're starting from 0. The 0th power is 1. My notes are here on the wall. Each place is like, so you've got, this is 1, this is 2, this is 4, this is 8, this is 16, this is 32, this is 64, this is 128. So yeah, if you count, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It's like that. I guess I didn't really need this hand to just count up to 16, but yeah. By the way, on one hand, you can count up to 31 because then the 6th place would be the 32nd place. So obviously it has to, it has to all add up and be consistent, whatever. Yeah, so the places, they double in base 2, they multiply by 10 in base 10, etc. For counting in binary, a useful way of thinking about it, at least for me, this system I go with is like, if you're going up by 1, and for any number, if all the previous ones are 1s, then that will go up as well. So this is 1, 2, 4, 8. This is 7. 4 plus 2 plus 1, that's 7. Add 1 to that, you get 8. And yeah, let's say if we have this. This is 15. 8 plus 7, as we previously mentioned. There's only 1s below this one, and this one's a 0. If you add 1, it's just like that, basically. Just like how if you have 1099 in base 10, if you add 1, you get 1100. Same thing in binary. So like 1011, add 1 is 1100. So the second way is based on base 12, or duodecimal, as I don't know, some may call it. Duodecimal is interesting because some people believe it's the system we humans should be using, because 12 has more factors. You've got, it's divisible by 2, 4, 6, and 3. Yeah, so in base 12, that you can count in a more compact way. On one hand, count up to 12. Just like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's easy. You could be writing and count. If you want more than that, you will need 2 hands, but I'd argue it's worth it since you could get up to as far as 156. So let's say, you start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, decal do. Do, dozen, whatever. 10, 11. Let's just count in base 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37. So, you know, these are counting multiples of 12. These are counting the in-betweens, basically. With when it's here, it's a multiple of 12, and then it's plus 1 plus 2. A multiple of 12 plus 1, a multiple of 12 plus 2, 3, 4, 5, all the way up to multiple of 12 plus 11. Then you move up one here, then, you know, that's how it works, basically. So it's like you've got the units place here, this area, and then you've got the 12s place. So you get up to a gross, or 144 in base 10. Yeah, there's a 6-year-old video about base 12 and counting, and, well, probably more about base 12, but still, yeah, it's good if you're interested for more information about base 12 and stuff like that. Could check that video. It should be here. Should be the top right corner. It's 4 minutes and 39 seconds, so it's less than this one. Got time to spare for this one, you know, surely maybe you've got more. What I've mentioned so far are not my own ideas. I'm merely holding a torch to something that is already sunlit. However, through making this video, I have been able to think about these ideas more, and these ideas have inspired me. I've come up with 3 ways to count using the subsections of fingers, these bits, you know, based on the dozenal counting system. And one way is with hexadecimal, base 16, and it's very similar to duodecimal. The only change is that you start using the area below the fingers, and that counts as numbers as well. So you could count up to 16 on one hand, and as far as 256 on 2 hands. You know, like going up to 16 here, then count 1 there. You know, well, okay. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, F. 1, 0. Or, to be more mathematical, you could start from 0 and then you get up to 255. You know, you're only sacrificing 1, but it makes more sense. So it goes like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, F. 1, 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on, all the way up to F, which is 255. So one hand stores the units and the other hand stores the 16s place in base 10 speak, I guess. Another method uses base 4, also being able to count up to 255, and also uses both hands. And that is, instead of using base 16, you're using base 4. You basically split it up, but it uses both hands. I guess it's a more compact way, in a sense. But it is maybe a bit trickier, you know, for the dexterity and whatnot. Yeah, so the places are the units, the 4s, the 16s, the 64s. Yeah, so it's like 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 2, 3, 4. So 0, 0, 1, 0. That is 4 in base 4. Then 0, 0, 1, 0, 1, 2, 3, 2. So 0, 0, 2, 0 is 8, and so on. It's kind of hard to see, but it's easy to understand if you're actually doing it. I'll have pictures with like without my fingers in the way, showing how it works. Then in a similar way, since the 4 fingers are split into 3 sections with the rows and columns swapped, I guess you could say, you can also count in base 5. Oh, I misspelled count. I spelled it quint. Sorry about that. Yeah, so like this. So that's, let's say, zeros at the bottom here. Then 0, 1, 2, 3, 4. I guess the way I've done it, it's flipped, but you know, I just personally I prefer it with my right hand. Sorry, I just bumped the mic and it's on toilet paper. Yeah, so like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Yeah, so you've got the units, the fives, the 25 section. And using this method, obviously, since there's only 3 rows, the highest you can count up to is 124, starting from 0 at least. Of course, I couldn't possibly end with something less than I started on. So going back to the base 4 counting, if you include the thumb, but 0 is like not a place on the thumb, so it's like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and so on. So then you've got the units, the fours, the 16s, the 64s, and the 256s. Then you could, in theory, count up to 1023, just like as if you were doing it in binary. It's hard bring up the fourth finger up, the ring finger. Just like that, I've counted up to, oh, sorry, 1, 2, 4, 128. I've counted up to 128, just like that. It's so easy if you practice with your fingers. I don't know. Yeah. One final note about that I haven't written a script for this. I hate the word script. It's like, nah, goodness me. But it helps organize your thoughts, make sure you don't forget anything. It's useful. But not a big fan of writing. I guess that's why I do maths. But I still have essays to do, unfortunately. Anyways, um, yeah, with binary, there's in this brilliant book. There's a bit about ASCII, and it uses binary. So I've been talking, and my cameras have been listening because I didn't turn on the module which records the microphone audio. There's just been noise because it's frankly not the greatest quality, but well, it's good enough for me. So whatever. But I forgot, and hey, now we've lost it. Anyways, so